Welcome back, everybody. In this video, we'll be starting chapter 10. As always, when we're starting a new chapter, it's a good idea to look ahead, see what it is that we're getting into before we get into it. So chapter 10 actually has a total of 5 sections in it. In this course, we'll only be covering the first 3. Chapter 10 is about what's called analytic geometry. Specifically, it's about the conic sections. And what is meant by that is if you take 2 cones, as shown in the picture here, and 2 circular cones, and point them so that their tips, what you think of their tips, are touching, and then intersect that resulting 3D shape with a plane, called making a cross section or a section, then that generates a 2-dimensional shape. So if you make the cut parallel to one of the circular bases, from that cone structure, you get a circle. If you make it passing through one of the cones but not parallel to the base, you get what's called an ellipse. If you make it so that it crosses through one of the circular bases, but only one of the circular bases, you get a parabola. And then if you have it so that it crosses through 2 of these both cones, then you get a hyperbola. So in this chapter, we'll be looking at this sort of shapes and their equations and some of the applications of these things. Along the way also, we'll take a quick look at circles. Although this section, this chapter, the first section is on ellipses. That'll be 10.1. We're going to have also a 10.0, which you don't see in the textbook. So your resource here will be just the notes, really. That's on circles. And then a new kind of 10.4 will be about identifying conics in general form. So you'll see those listed that way in the exercises, but there aren't kind of corresponding sections in the textbook. So let me know specifically if you have questions about that. So we're going to get started with circles, and then after that, we'll go on to take a look at the ellipse. In order to talk about circles even, we need to actually review the distance, or look at the distance formula. So what the distance formula is like, if it's not familiar to you, is a formula we can use to find out how far apart 2 points are in the plane. And so this picture is probably pretty familiar to you from calculating things like the slope. Right, the slope is the change in y divided by the change in x, right? y2 minus y1 over x2 minus x1. Depending on your background, you may have figured out before the midpoint of that line. What we'll want to do in this section, as preparation for looking at circles and stuff, is to figure out how far apart those 2 points are. And so the approach that we're going to take is to use the Pythagorean theorem to help us get this done. So we're going to take a look at that kind of bluish line, the diagonal, as a hypotenuse on a right triangle. Okay, so we've got this right triangle then with the kind of given length as the hypotenuse. We're going to use the Pythagorean theorem to help us get this done. And just in case the Pythagorean theorem is not real memorable for you, if you have a right triangle, let's say with sides of length 3, 4, and 5, notice that it's true that 3 squared plus 4 squared is 9 plus 16, and that's equal to 25, which is 5 squared. It turns out that that relationship is true in general. A squared plus b squared equals c squared. That's the Pythagorean theorem for a right triangle. If you need to know more about that, let me know. Otherwise, I'm going to assume that you're familiar with that and comfortable with it. Okay, so we're going to use that right here to help us come up with the distance formula. So to do that, we're going to need, probably helpful to have the coordinates of this point down here where the right angle is. So if this is going to be a right angle, you'll notice that the x-coordinate here will have to be the same as the x-coordinate at the top, so that will have to be x2. The y-coordinate will have to be the same as the point to your left, and so that will have to be y1. Okay, so then from here we can figure out the length of the green line. That will be x2 minus x1, right? And then for the red one, that will be the difference of the y's, y2 minus y1. Okay, and then the distance we're looking for is going to be the hypotenuse of that triangle, right? So using the Pythagorean theorem, we'll have that d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, and that's the Pythagorean theorem. And then it's customary usually to just take square roots of both sides so that the distance will be the square root of change in x's squared plus the change in y's squared. Okay, and that's the distance formula. We're going to need that to help us do circles. If you have 2 points, x1, y1, and x2, y2, that's how you find the distance between those 2 points. Okay, so just to try it out one time, we want to find the distance between the points 1, 4, and 2, negative 9. So the distance will be the change in x, so 1 minus 2 squared, and then the change in y's, 4 minus negative 9 squared, and then we want the square root of that. Be careful you don't forget the square root. A lot of times people do, so be careful about that. So 1 minus 2 is negative 1. Negative 1 squared is 1. 4 minus negative 9, that's the same as 4 plus 9, which is 13. 13 squared is 169. So we'll have these, too far. Square root of 170. Okay. All right, and then if you like decimals, that's just a little over 13, right? So that is like 13.038 about. Okay. All right, so that's just a little bit about the distance formula in preparation for us to do circles. Like I was saying, if you need help with that or a little more review of either Pythagorean theorem or working with these square roots, then let me know. Okay, meanwhile, we're going to use that to help us develop the formula for the equation of a circle and then work with that just a little bit. Okay, so if you think about how to describe a circle, how would you describe a circle to somebody who's never seen one? You're doing it over the phone, so you can't draw a picture or something. Okay, a circle is the set of all points. You can't say round, okay? It's the set of all points that are the same distance from a fixed point, right? So you've got this point called the center, here shown in the picture in red with coordinates hk. Tradition here is that it's called hk. And the circle is the set of all points that are the same distance from that, right? I mean, if you wanted to say, okay, well, there's this thing and it's kind of round around a center. Well, okay, that's kind of round, but how do you quantify that something is round, like exactly round, like you think of a circle? Well, on a circle, the distance from the center to the circle is constant, right? It's the radius of the circle, okay? And so that's r, okay, our radius of our circle. Let's make that a little thicker. Okay, so it's the distance, that distance r to any point x, y on the circle is constant. So we can use that distance formula we just developed to write down the equation of the circle. So let me recopy the distance formula here for your reference. So we'll take the change in x's, we'll square that. We'll take the change in y's, we'll square that, and then take the square root of it. Okay, there's the distance formula. And so now we want to put on the specifics for our circle. Okay, so instead of d for distance, we'll have r for radius. And then, all right, so we're going to take the specifics off of my circle picture and insert them into that distance formula. So the x change will be x minus h, that's squared. And then the y change will be y minus k squared. And then for the equation of a circle, it's kind of customary to square both sides. So you have r squared is equal to x minus h squared plus y minus k squared. Okay, and that's the equation of a circle. And this circle has radius r and center at hk. Okay, and if you're good at memorizing stuff, you can memorize that. I just remember this because I've been doing this, but if you're good at memorizing things, you can memorize this. Otherwise, if you remember the picture of a circle and how we've labeled the pieces, and you know the distance formula, then you can kind of recover that circle formula whenever you need it. Okay, so that's circle equation. So this just kind of restates it. Of course, if the circle is centered at the origin, that is h and k are 0, we get what's called the unit circle. It's x squared plus y squared equals r squared. Okay, so we want to graph a couple of circles. So let's do that. Okay, so here it says graph x squared plus y squared equals 9 first. So let's do that one. All right, so for this one, if you like, just to play with the formula, we could say this is x minus 0 squared plus y minus 0 squared equals 3 squared. So you can see that the h and k are both 0 here, and then the radius is 3. So what I usually do is I draw the kind of top and bottom and left and right of the circle, if you like, and then just kind of connect the dots with some arcs to draw a circle kind of shape. All right, so let me label some intercepts. So we've gotten our circle, okay, centered at the origin and radius 3. All right, so this one, we need to think about where this one is centered. So here you want to be careful, okay? So the equation that we developed has x minus h and y minus k in it. So when you see something that looks like this that says x plus 2, you really want to think about how that is x minus negative 2 squared. Okay, so the x coordinate of the center is not going to be at 2, but rather negative 2. Okay, so it'll be at negative 2 and positive 1. Okay, so this one's not centered at the origin. The radius, though, is 2, right? Sorry about that. No. Okay, so the radius is 2, right? 2 squared is 4. So from the center, I'm going to go to the right, up, down, and left to make the right, top, left, and bottom of the circle. So let me go up 2 from here, right 2, left 2, and then down 2. Okay, let me take that grid off because it's annoying. There we go. All right, so there's good. So our center is at negative 2, 1. And then just for fun, let's go ahead and figure out what the other coordinates are. So this one will be at 0, 1. This one will be at negative 2, 3. And then on the left side, we'll have negative 4, 1. And then we'll have 2, negative 2 rather, and then our radius was 2, so we'll go down to negative 1. Okay, so there's our coordinates for kind of the extremes for this circle. You can give yourself some bonus points if you can figure out where those two intercepts are, okay, and figure out what the labels there have to be. Okay, so we've drawn a couple of circles, one centered at the origin and one not. Okay, and so, all right, so what we want to do next is work on finding some equations of circles. So that will be now. So we want to find here, instead of given an equation, drawing a graph, we want to actually produce the equation. Okay, so let's do that. So the equation of the circle with radius 6 and center 2, -5. So what I'm going to do is start by writing down the equation of any circle. So x minus 8 squared plus y minus k squared equals r squared. So that's kind of, I like to do that partly because I'm here showing you this, but also I think it's a good idea to write down the equation every time that you use it. That helps you remember it. It also helps you put the right things in the right places because I'm going to be putting the things directly below, like the k and the h and the r, as they appear in the formula. Okay, so we'll have x minus 2, our h is our x coordinate of the center, x minus 2 squared plus y minus -5, got to be careful about that, and that's squared, and then our radius is 36, or 6 squared, so our r squared is going to be 36. Cleaning this up just a little bit, we'll have x minus 2 squared plus y plus 5 squared equals 36. Okay, so that's the equation of a circle with radius 6 and center at 2, -5. Okay, all right, so this one will be a little fun too. These points are the endpoints of the diameter of a circle. We want to find the equation of the circle. So we know that to find the equation of a circle, we need to know its center and radius. So far, all we have are 2 points that are endpoints of a diameter of a circle. So maybe a little sketch would help. It doesn't have to be a very great looking sketch, but that's okay. So we'll have -1, 3. And then the other one, 7, -5. I guess that's going to look more top to bottom. So -1, 3 and 7, -5. Okay, and so we have basically a diameter of that circle. So to find the center, I know that the center will be midway between those 2 points. So we'll take the average of the x coordinates. So -1 plus 7, and that's divided by 2. That will give us our x coordinate of the center. And then 3 plus -5 divided by 2. That'll give us our y coordinate of our center. So the center will be at -1 plus 7 is 6. 6/2 is 3. 3 plus -5 is -2. -2 divided by 2 is -1. So the center will be at 3, -1. Okay, and then to find the radius, what we'll do is we'll take this diameter we were given and we'll find out its length and divide by 2. Or if you want, you could take the distance from the center we found to either of those 2 points. It doesn't really make a difference. If I had some doubt about whether the center was correct, I may not want to use it in any calculations, but so I think for that reason, we'll just stick with the diameter. We'll divide that by 2. Okay, so changing x, so we'll say -1 minus 7. We'll square that. Then changing y, 3 minus -5. We'll square that. We'll need to take the square root of that off. Okay, we're working on getting the radius. Right now we got that. This calculation will give us the length of the diameter. -1 minus 7 is -8. -8 squared is 64. 3 minus -5, that's the same as 3 plus 5. 3 plus 5 is 8. 8 squared is 64. And so we need the square root of 64 plus 64. That's going to be 128 or 2 64s. Let's just leave it at that. So this is 64 times 2. And so that'll be 8 square roots of 2. Okay, so that's the length of the diameter. Okay, for the equation of the circle, we need the radius, which is half that, right? So the radius will be 4 square roots of 2. Okay, and so now let's start plopping in things into our equation. So x minus h squared plus y minus k squared equals r squared. Okay, and so now x minus center was at 3. for the x coordinate. The y coordinate was at -1, so that'll be y plus 1 squared. And then 4 root 2 squared. That'll be 4 squared root 2 squared, or 16 times 2, 32. Okay, so for this example, we were given the endpoints on the diameter of a circle. We found the midpoint of those by averaging the x and y coordinates. That told us the center for the circle. And then we used the distance formula to find the length of the diameter, and then we divided that by 2 to get the radius, and then we dropped all that into the equation of a circle. Okay, all right, so now for this next one, this one's going to be kind of fun. For this one, we want the center and radius of the circle. But what's different is that this thing is all multiplied out already. So we know that the equation of the circle, or a circle, looks like this. So it's got some binomial with an x in it and a binomial with a y in it, and then the r squared, which is constant, appears on the right. So this one does have that 21 on the right, but this also has first degree terms in both x and y. It isn't just x squares and y squares. So what we're going to need to do is do some algebra to rewrite this from the given form into this kind of standard form equation for a circle. And the method that we're going to use for this is completing the square. Completing the square is usually a method that we learn kind of on the way to doing the quadratic formula for solving a quadratic equation. And it's based on, just a quick detour here for completing the square, then we'll get back to our circle, okay? So for completing the square, it's based on the formulas that we use for multiplying. X plus a squared is x squared plus 2ax plus a squared. And then there's a corresponding one for subtraction. Okay, we've seen this before some. We can use this to multiply binomials. We also use it to factor. So if I asked you to factor x squared plus 10x plus 25, then you could say, okay, well, half of 10 is 5. 5 squared is 25, so it factors as x plus 5 squared. If we add y squared minus 16y plus 64, then we'd say, okay, well, yeah, half of 16 is 8. 8 squared is 64, so that's got to factor as y minus 8 squared. In fact, once you know that kind of middle term, you don't even really need to know that constant term in the back. So if I told you, let's factor x squared plus 22x plus something, okay, you can figure out the something. What does the something have to be? Half of 22 is 11. 11 times 11 is 121. That constant term would have to be 121, and we'd have x plus 11 squared. If we had y squared minus 24y plus, now it would be y minus something squared. Half of 24 is 12. 12 squared is 144. Now it factors y minus 12. Okay, so that's kind of completing the square. If you need to know more about it, let me know. You can see me in office hours or send me an email or something. All right, so that's the method we're going to use to help us rewrite this equation of the circle. Like I said, usually this is used to help solve quadratic equations before you learn the quadratic formula. So it's also used for other purposes. But here we're going to use it to help us rewrite our circle equation. So let me rewrite this so that I'm just going to collect the x terms on one side, and I'll leave a little space in here. And we'll have y terms coming next. We'll have y squared minus 10y. And then I'll leave that plus 21 over here on the right side. So here you can see that I haven't really changed anything. That is, 21 is still on the right side of the equals by itself. The other terms are still on the left side. I've just physically spread them out a little bit. And then the x terms are by each other and the y terms are by each other. So I've used commutative property for addition on this. So then, going back to what we were doing here with completing the square, if we want to make perfect squares out of this, for x squared plus 4x, we need to think about what would we have to add to make that a perfect square. Half of 4 is 2. 2 squared is 4. We'd have to add 4 to it. Of course, to preserve the equality, we're going to add 4 to both sides of the equation. For the one for y squared minus 10y, okay, it would have to be, well, half of 10 is 5. 5 squared, 25. We'll be adding 25 to both sides of the equation. Okay, and so once you've gotten that far with it, you've got a pair of perfect square trinomials that factor easily. So we'll have x plus 2 squared, and then y minus 5 squared. And then on the right side, let's add all that up. That's 25 plus 25, which is 50. Okay, and what is it we want to know is the center and radius. Okay, so the center is at -2, 5. Okay, and then for the radius, notice that the radius is r squared is equal to 50. Okay, so then r will be the square root of 50, or 5 root 2. Okay. Be very careful here. It's common for people to look at this 50 and say, okay, well, 50 times 50 is 2,500, so that's the radius. But notice that this is already squared, right? You don't want to square it again. It's already squared, so you want to take the square root of that to find the radius. All right, so that gives us the center and radius of this circle. That takes care of all we were going to do as far as review on circles before we do ellipses. And so let me know on that if you have any questions. We, of course, still have more work to do. We'll be going on to section 10.1 next. But in the meantime, let me know if you have any questions, and have a great day.